So this video is about gravity on the flat Earth and on the real Earth. There is a popular twice daily echo chamber called Flat Earth Debate, and in that show celebrities often discuss how there's no such thing as gravity. Now Mr. Anthony Riley of that debate refuses to answer questions since I don't have enough subs, so I'm making this video to hopefully get some, and get some of my questions answered. That's all I want, a bit of discussion. You'll see I've noticed that flat Earth is all about statements, but not about backing those up with any explanations. So here we get into gravity. Apparently, according to Mr. Riley, gravity doesn't exist. I can see how he might think that, because looking at his hair on a typical day, it does seem to defy gravity. Anyway, it's all to do with relative density apparently. If an object is more dense than the fluid around it, then the object will fall down. No explanation for why it goes down, of course, it just goes down. If an object is less dense than the fluid around it, the object will go up. You can see in the diagram here, there's some oil in some water. The oil is less dense than the water, and so it floats to the top. So, flat Earth 1, globe 0? Well, not quite. One related question: since we know that air pressure gets greater as we get closer to the Earth, shouldn't objects fall upwards rather than downwards? In fact, maybe there's no direction to it. We'll see that basically the force of an object on the top and the bottom creates a pressure differential, which in Archimedes' principle basically says that the equivalence of the weight of the displaced fluid is what causes the buoyant force, but you need gravity to create that buoyant force. So go back to our tower. We've got the tower here that they often like to show on the flat Earth debate, where there's a bunch of different fluids, all different densities, and they all settle at a really, nice different levels. And there's the happy cherry tomato that Nathan loves to talk about. Well, what we can do is we have a video on YouTube, and I'll put the link in the show notes. We basically have a 0G flight, whereby a plane drops out of the sky at exactly the same speed as you would be falling due to gravity. So they kind of cancel each other out. And due to that, we get some really interesting results. So you'll see here, we've basically got, while they're still under gravity, we've got three fluids in a tube, and they're separating out due to the gravity, due to the different relative densities, let's say. Now, as the plane drops out of the sky, the chap shakes it up, and look at that, it doesn't separate. Now admittedly he's doing it in a bit of a scrappy way, but it's not separating. And the reason why it's not separating is because relative density doesn't have a direction. It needs a force. You take that force away, there's no direction. So it just stays as a big muddle. And then gravity comes back, and there you go. It separates again. They do it a few more times in this video. I'll link to it. It's a very, very good video. Obviously 0G flights only last for a few seconds, so not very long. But it got me thinking, because if you run through the math of all of this, as we go back here, basically it does come down to the point where gravity can be cancelled out from the equation. It can just, in this instance, just be shown to be relative density, one density divided by the other, to whether it goes up or down. So, that's a bit of a worry, right? But then it got me to thinking there's more to life than up and down. There's also rotation. And so it takes me on to another video, and this is by a YouTube channel called Action Lab, and it's very good. He's got a lot of good videos on Action Lab for lots of different experiments that you can do. And in this one, he's putting a test tube into some water, and you can see it's very, very unstable. And that's because the center of gravity, the center of mass, the center of buoyancy are quite high up. And so there he's just trying to stabilize it by putting it against the side of the tank. You see what happens a little later when he adds in some ball bearings. So you put in some ball bearings there, and it's lowering the center of gravity, which incidentally is the same as the center of mass. So not quite enough there, a bit more stable. Puts in some more. Bit more stable again. And there we go, pretty stable. And that's because he's lowered the center of mass right down low, and the center of buoyancy is staying higher up. Yes, they're two different entities acting through two different places. And the reason why it creates stability is because of this. You've got the center of buoyancy and the center of mass. One is higher than the other. And the video is very good at explaining this. And that's why you get some boats that are stable and some that are unstable. So this is essentially it. You've got your center of buoyancy and your center of mass or gravity, and they're trying to line up. They'll always line through one single line, but they cause a rotation. If they're out of that line, they're going to cause a rotation to get back into alignment, and that might even be the Arwin alignment, the density buoyancy line. Who knows? But it causes a rotation, as they say, and it's required. What you require to have to create a rotation is two forces that are creating that moment arm, and it's well known in engineering that that exists, that you have forces creating rotation moments. So that's what I'd like to know. I'd like to know from Mr. Riley how that can exist. How is it that if it's just relative density, how can we have these different two forces acting on an object? Surely this should just be one. And you don't even think that's a force to begin with. So please have a think this over, and maybe just as usual deny it all. Maybe make something up. Maybe it's collimation. Maybe it's something to do with Airy's diffraction. I don't know. But you know what? I'd be interested to find out. So maybe you can think about it and actually answer me this time. Or maybe we're just all liars, like we usually are, Nathan. You know, going up at the end, calling everybody liars. Yeah, I know, they're all a bunch of liars.